Hello, this is Miss Moore, and today during chemistry we're going to discuss scientific notation and mathematical calculations. Today's essential question: how do you do mathematical calculations with numbers written in scientific notation? And as a quick warning, today we're going to incorporate everything we've learned so far, including significant figures when doing calculations, and scientific notation. Because we're doing calculations today, make sure you have your calculators handy. Okay, you guys ready? Let's do it. Doing calculations with numbers written in scientific notation is not mathematically difficult. Okay, the math itself is very straightforward. The part that can be a little tricky is that you need to be careful. There's several steps, and you could get yourself lost. So lots of places for mistakes, but it's not mathematically difficult. All right, let's start with multiplying numbers written in scientific notation. So we're going to use the example 3.03 times 10 to the fourth multiplied by 6.29 times 10 to the second. And remember from the last lecture that times 10 to the fourth does not mean multiply by 4, right? The way you would say this problem is 3.03 move the decimal 4 times 6.29 move the decimal 2 times. So the only multiplication is right there. Okay? All right. So the first step in multiplying numbers written in scientific notation is to multiply the coefficients. So what is a coefficient? A coefficient is just a regular number, not a superscript, subscript, exponent. It's just a number. So in our problem, 3.03 and 6.29. So we're going to multiply our coefficients, 3.03 times 6.29. And if you could put that in your calculator along with me so we can make sure we all agree on the answer. And I got 19.0587. All right, so again, we multiply the coefficients, 3.03 times 6.29, and got 19.0587. All right, now we've got to deal with sig figs. This number here has a lot more figures or digits than either one of the numbers in our problem. So let's figure out our number of sig figs. Remember, when you're determining number of sig figs after doing multiplication, you look at the number with the least number of sig figs in the problem. So for the first number, 3.03, what's significant? The 3 and the 3 are significant, right, because they're non-zero digits. The 0 is also significant because it's between non-zero digits. So 3.03 has 3 sig figs. And if we look at the 6.29, we have 6, 2, and 9, all of which are non-zero digits, so it also has 3 sig figs. So we need our answer to have 3 sig figs, which is going to be the first 3 digits, 1, 9, and 0. So we have to drop the 5 on. So we look at the 5, the first number we're going to drop, and remember, if it's 5 or larger, what do? We are going to round up. So our final answer with appropriate sig figs for multiplying coefficients 3.03 times 6.29 is 19.1. So we've multiplied the coefficients. We now need to deal with the rest of the numbers in the problem, and those are the exponents. If you remember from the last lecture, the exponents are the little numbers attached to the 10 that tell us how many times and in what direction to move the decimal. All right, so when you're multiplying numbers in scientific notation, you multiply the coefficients and you add the exponents. So we're going to add the exponent 4 and 2, and that gives us a new exponent of 6. So we're now have moved the decimal 6 times. Okay, again, we added the exponents. You multiply the coefficients and you add the exponents. So the next step is to put our two answers together. So when we multiplied the coefficients, we got an answer after applying significant figures. We got an answer of 19.1. And when you add the exponents, we got an answer of 10 times 10 to the 6th. What we need to do now is clean this up a little bit. We did the math right. Our number is mathematically correct. However, it is not written in appropriate scientific notation. If you remember from the last lecture, when you write numbers in scientific notation, it comes in two parts. The first part is a number written between 1 and 9. The second part is the exponent. The exponent's fine. However, is 19.1 between 1 and 9? It's not. So, what we need to do now is move the decimal and the coefficient and change the exponent if necessary. So what do we need to do to make 19.1 have only one number in front of the decimal? Well, we move the decimal and make it 1.91. All right, then we need to take note of how many times we moved the decimal. We moved it once. And because it's an exponent, I'm going to put that number back up here with the other exponents. Okay, and now remember we have to figure out the sign of the exponent, if it's positive or negative. So we look at the original number, 19. Is that number a big number or a small number? Bigger than 1 or smaller than 1? Well, 19.1 is bigger than 1, so the exponent is a positive number. So right now we have a new exponent of 10 times 10 to the 6 plus 1, which we would write as 7. So our final answer is 1.91 times 10 to the 7th. So now you know how to multiply numbers written in scientific notation. You multiply the coefficients, you add the exponents, you put the answers together, checking for appropriate significant figures and scientific notation. All right, let's move on to dividing numbers written in scientific notation. Okay, let's now divide numbers written in scientific notation. The good news is this is not a whole lot different than multiplying. Okay, so step one is instead of multiplying the coefficients, we are going to divide the coefficients. And our coefficients in this problem are the 3.083 and the 5.3. So we'll have 3.803 divided by 5.30. And if you guys could put that in your calculator and make sure you agree with my answer, I got 0.717547,169. Okay. Next, let's deal with the significant figures. And remember, this number of significant figures in our answer needs to be the same as the number of significant figures, the least number of significant figures in our problem. So let's look first at 3.803. Is a 3 significant? Yes, because it's a non-zero digit. And that is true also of the 8 and the other 3. What about this 0? Is it significant? Well, it's between two non-zero digits, so it is significant. So 3.803 has 4 sig figs. Okay. How about the 5.30? The 5 and the 3 are both significant because they're non-zero digits. What about that 0? It's not between non-zero digits. However, it is after a decimal and there's a non-zero digit before it, which makes it significant. So 5.30 has 3 sig figs. So how many significant figures should our answer have? It should have 3 sig figs because it needs to be the same as the least number of sig figs. Okay, so we need to take the first 3 significant figures from our answer. So, can the 0 be significant? It cannot because it's not between non-zero digits, and while it's before a decimal, there's no non-zero digit before it. So, the 0 cannot be significant. So the numbers we're going to keep are the 7, 1, and 7. Okay? So we're going to drop the 5 and beyond. And because 5 is 5 or greater, that means we're going to round up. So for an answer, we're going to end up with 0.718. Next, we need to deal with the exponents. So we're going to, this time, subtract the exponents. So the 3 and the 6. Okay, so, and you need to do it in order. So we're going to have 3 minus 6, which equals negative 3. So our exponent is now times 10 to the negative 3. Okay, let's put our two answers together. When we divided the coefficients, we ended up with 0.718. And when we subtracted the exponents, we came up with, move the decimal, negative 3 times. All right, we're done. Or are we? Is that the final answer? It's not. What's wrong with it? 0.718 times 10 to the negative 3 is not appropriate scientific notation. We do have an exponent, which is fine. But what's wrong here is the 0.718. That is not a number between 1 and 9. So once again, we're going to have to move the decimal and the coefficient and change the exponent. All right, so to change 0.718 to correct scientific notation, it's going to need to be 7.18. So how many times do we have to move the decimal to get from 0.718 to 7.18? We had to move it once. And again, I put the exponent up here with the other exponent. All right, now the sign of the exponent. Is it positive or negative? Our original number is 0.718. Is that a big number or a small number? Is it larger or smaller than 1? It's small. Small is a negative. So our exponent is now times 10 to the negative 3 minus 1. So instead of writing 10 to the negative 3 minus 1, we'll write 10 to the negative 4. So we have, as a final answer, 7.18 times 10 to the negative 4. So when dividing numbers in scientific notation, you divide the coefficients and you subtract the exponents. And that's it for today, except for a few practice problems. If you feel pretty good about this, go ahead and move on, try the practice problems. If you're not feeling comfortable, why don't you rewind, rewatch, and then try the practice problems. All right, it's time for you to check your understanding. So I'd like you to try to do these problems on your own. So you're going to hit pause, try to do them, and then you can hit play again and I'll go through them with you. Number 1 is a multiplication problem. So the first thing we're going to do is multiply the coefficients. So we'll have 3.45 multiplied by 3.449. And I got an answer of 11.89905. Okay, I got to deal with my significant figures. So I go back to my problem, and the first number, 3.45, has 3 sig figs because it's made up of all non-zero digits. The second number is also made up of all non-zero digits, so it has 4 sig figs. So how many significant figures is our answer going to have? 3. So we're going to keep the 11 and the 8. We're going to look at the 9, drop everything from the 9 on. And because the 9 is 5 or bigger, our final answer for multiplying coefficients is going to be 11.9. Next, we need to deal with the coefficients, the negative 3 and the 5. And because this is a multiplication problem, we multiply the coefficients, we add the exponents. So we're going to have negative 3 plus 5. And that gives us 2. So our exponent is going to be times 10 to the 2. So if we put our two answers together, we have 11.9 times 10 to the 2. Okay, and all we have left to do is to turn this into appropriate scientific notation. So we need to rewrite 11.9 as 1.19, and we had to move the decimal once. And because 11.9 is a big number, it's bigger than 1, the sign is going to be positive. So our exponent is going to be times 10 to the 2 plus 1 or to the 3. So our final answer should be 1.19 times 10 to the third. Number 2 is a division problem. So the first thing we need to do is divide the coefficients. So I'm going to have 8.56 divided by 9.22. And my calculator gave me a really big number, 0.9284164885. Okay, if we go back and look at the sig figs, both numbers in the problem have 3 sig figs because they are made up of non-zero digits. So that means our answer needs to have 3 sig figs. Does the 0 count as a sig fig in the answer? It can't because it's not between non-zero digits, and while it's before a decimal, there is no non-zero digit before it. So the first 3 sig figs are the 9, the 2, and the 8. So we're going to drop from the 4 on. And because the 4 is 5 or less than 5, we're just going to drop. And our answer will be 0.928. Okay. Next is the exponents. We have 3 and the negative 5. So when we're dividing, we subtract exponents. So we're going to have 3 minus negative 5. Okay, so when you have a minus and minus, what do? You add them, right? So we end up with 8. So our exponent is times 10 to the 8th. All right, we put the answers together. We get 0.928 times 10 to the 8th. And once again, this is not in appropriate scientific notation. So let's fix that. 0.928 should be written as 9.28. And we had to move the decimal 1 time. So our exponent's going to be 1. And 0.928 is a small number. It's less than 1. Small is negative. So our new exponent is times 10 to the 8th minus 1, which is to the 7th. So we have our final answer is going to be 9.28 times 10 to the 7th. Number 3 is a multiplication problem. This time I gave you some extra numbers, see if you could figure that one out. All right, so again, when we have a multiplication problem with scientific notation, first thing we do is multiply the coefficients. So we're going to have 2.11 times 4.303 times 3.9, and that gives an answer of 35.409387. Okay, our sig figs. The first number has 3 sig figs because they're all non-zero numbers. The second number has 4 sig figs. The 4, the 3, and the 3 are all significant because they're non-zero digits. The 0 is significant because it's between non-zero digits. And the third number only has 2 sig figs. They are both non-zero numbers. Okay, so we're only going to keep 2 significant figures this time, the 3 and the 5. So we look at the 4. The 4 is smaller than 5, so we're going to drop, which means our answer from the multiplication of the coefficients is going to be 35. Next, we need to deal with the exponents, and when we're multiplying Numbers in scientific notation, we add the exponents. We have the 12, the 4, and the negative 7. So we're going to have 12 plus 4 plus negative 7, which gives us an exponent of 9. So our exponent is going to be times 10 to the 9th. All right, so let's put our answers together. We have 35 times 10 to the 9th. All right, once again, we need to change this into correct scientific notation. So 35 should be written as 3.5. And we had to move the decimal. Well, okay, where is the decimal? If there's no decimal written, the implied decimal is at the end, right? It's implied right here. So we had to move the decimal once. And 35 is a big number, right? It's bigger than 1, and big means positive. So our exponent is move the decimal 9 plus 1 places, or 10 places. So our final answer is 3.5 times 10 to the 10th. And that's it for today.